Welcome to Openbox. Openbox aims at bringing easier understanding of open problems that help in finding solutions for such problems. For the set purpose, I'll be interviewing researchers, practitioners who have published works on open problems in artificial intelligence, machine learning, and related subjects. This is to collect simplified understanding of the open problems, and these will be published as part of a podcast series. My name is Sundar. I'm an ethics and risk professional and an AI ethics researcher. I'm the host of this podcast. Ideas emerge when curiosity meets clarity. Openbox is an initiative to bring clarity for those curious minds to look into real world open problems. This project is done in collaboration with For Humanity. For Humanity is a non-profit organization dedicated to minimizing downside risks of an autonomous system. They develop criteria for independent audit of AI system. In case you want to know more about them, the link is provided in the comments. Today we have with us Rafael. Rafael is a master student at the University of Campinas, working on offline reinforcement learning applied to agile drone navigation. He's interested in intersection between offline RL and robotics. I'm glad to be having a conversation with him, and we're going to be covering a paper which he co-authored and it got published in March 2022. It's a survey of offline reinforcement learning, taxonomy, review, and open problems. Rafael, welcome to the show. Part two of the discussion with Rafael, we are discussing about open problems in offline reinforcement learning. And in the part one, he did discuss about a couple of open problems. He spoke about offline policy evaluation methods and lack of adequate benchmarks. We touched upon the ethical issues associated with that. Today, we're going to be covering a couple of more open problems, and Rafael will take us through those issues. To just jump in, Rafael, why don't you share more about the generalization issue that you had mentioned about in your paper?
Yeah, of course. So I think to start off the generalization issue, I want to contrast it with the non-issue that we sometimes have with online reinforcement learning, right? In online reinforcement learning, you can continuously interact with your environment, right? So you can continuously ask for more data and learn about other parts of your environment that you might not have visited. And the difference is that in offline reinforcement learning, we don't have this opportunity to interact with the environment and to explore the environment, right? So it makes it just that much more important for you to generalize with the data that you have. So in online reinforcement learning, what typically happens is that, or not typically, but in a lot of cases, we have overfitting. Like we overfit our policy to a specific environment. And that's perfectly fine. If our environment is able to capture all of the states and actions that we're going to actually see in the real world, overfitting to that environment is a perfectly fine thing to do. And we have the opportunity to do that in online RL because we can just keep interacting with all of the parts of the environment that are there until we overfit to it and we learn all of the intricacies of our environment. In offline reinforcement learning, we don't have that luxury and we have to deal with a very limited, not necessarily limited, but a static data set, right? So we need to be able to leverage this static data set and generalize beyond it, beyond the data that's there. And I think that's the main challenge in offline RL that doesn't necessarily happen so often in online reinforcement learning, right? And I think there are a lot of different fields in machine learning and or deep learning in general that are exploring the generalization ability of algorithms. And these fields haven't really been explored in offline reinforcement learning yet. So a few of them are like trying to explore a hierarchical structure of the problem, right? Trying to use this hierarchical structure to break the problem into different subproblems and possibly generalizing through those subproblems, through that bigger picture problem, and then for instance, learning a high level representation and then trying to learn specific representations in a downstream way, right, from that higher level hierarchical representation. Now, another technique that's often used in deep learning or the other paradigm of deep learning is representation learning, right? So where you in representation learning, you're not concerned with learning how to map an input to a data. You're trying to learn like what's the best representation that I can learn for that data, and you measure how good a representation is by testing it on several different downstream tasks, right? So those kinds of techniques are still severely underexplored for offline RL, and they're very important because those are the techniques that bring generalization to your methods. And I think generalization, like I mentioned, is a very important thing to have for any offline algorithm. However, one caveat is that I did some research recently, and there has been one, like in the past 30 days or so, one recent publication that specifically tackles the application of representation learning to offline reinforcement learning. So I think it's interesting that people are catching on to these issues and are starting to actually explore them, the possibilities there.
So it's very interesting to learn about the generalization problem. The way I see it is that when we're actually looking at generalizing to a given environment or in an offline reinforcement learning model, the challenge that happens is that there are layers of decisions that are made, and each of those decisions may be impacting ethical choice
Yeah.
of humans around it, right? So it may be impacting the choice that humans can make, or it may be constraining their choices. There are two dimensions that we are speaking about. One is the actions that offline RL does or the agent does, and on the other side that we are speaking about how it impacts humans who are going to be interacting with it, right? So how do you see that from a generalization problem? Is that something that is looked at as a focus at all in the field at this point in time? I know you mentioned that it's too early, we're just looking at some of the basic stuff to evolve there, but is the human impact or the ethical issues on the other side of generalization, is that being considered at this point in time?
Yeah, I would. Very inclined to say that no. Like, I don't think people are concerned with the human impact right now. But what you mentioned is extremely relevant in the sense that, like, you can't. Humans aren't necessarily generalizable, right? Like, to some extent, we are. We can get a batch of 1,000 human beings and see, like, this works for 99% of those human beings, but it might not work for 1%, right? And then if that 1% of the human beings, we're not going to see how, since we were trying to work with generalization and try to find the policy that best generalizes, we're only going to be finding optimal policies for those 99% of the human beings that have a specific configuration or so what I definitely see that there's a lot of potential difficulties that may arise in this generalization because on one end we're trying to find algorithms that are more generalizable, right? But on the other hand, we don't want to generalize beyond what we should, right? Like if we generalize too much, then it becomes almost too dangerous to do something on someone that has on an edge case. And when we're playing with you, when we're dealing with human
It's
lives,
very true.
yeah, it's
It's
not.
very true.
Yeah,
Yeah, this is you rightly mentioned about edge case, and it's really true that this is a difficult challenge per se. Specifically, if you're speaking about a scenario like medical diagnosis, and there are dynamics that are very very different because of race, because of
yeah.
environments people live in, and because of the treatment conditions, food habits, lifestyle, etc., etc. All of these factors cannot be data that can be plugged in a simulated environment and then treated on an ongoing basis, right? That creates a lot of issues on bias or ethics, as we spoke on, not just from a perspective of whether those humans have an ethical choice to, or for them to make a choice. This extends beyond that. With that, I just wanted to jump on to another point that you mentioned about how to leverage unlabeled data with reference to offline reinforcement learning, and how you see that challenge in this context.
Yeah, so I think just to preface a little bit this explanation, I think the idea behind leveraging unlabeled data is that not always, but what I mean by labels in reinforcement learning is the reward, right? So how good is a given action? How good was it for the patient? And that's extremely difficult to measure. In medical diagnosis, for instance, maybe you prescribe a certain drug A to a patient, right? And then that doesn't help. And then you prescribe drug B, and then that helps. You're not sure if drug B was the sole factor that helped the patient, or if it was a combination of drug A and drug B, right? And that makes it extremely difficult for you to actually find the true label. Like, so was drug A good drug or a bad drug? Did it harm the patient? Did it benefit, or was it neutral? You don't have that label for how good.
You don't have a way to measure the contribution of each of those actions to the
Exactly,
overall outcome as such, right? Because
exactly.
it is
And then
seen as a sequence and not necessarily as a composite impact collectively in that sense.
you might have the final outcome, right? Maybe you have access to the final label, but you don't have those intermediate labels. But
Yeah.
you still want to use that intermediate data to learn a good policy, right? And I feel like the challenge is that there are a lot of techniques that are today that are trying to explore how you can use this unlabeled data or this intermediate data that you don't know if it's good or if it's bad, and how can you leverage that to find and to improve your policy, right? Because that one might think that, okay, since I don't have an answer for this intermediate data, maybe I should discard it, right? But then the idea behind these methods is that no, we don't need to discard it. We can actually learn models from it, right? Or we can actually benefit the models that we have using this unlabeled data. And I think that one of the idea behind these techniques, essentially, like what I've been seeing in the research, is that unlabeled data, okay, it might not give you information about how good the policy is, but it gives you information about how the world works. So what I mean by that is, maybe I don't know if taking an action is going to be good or bad, but I know that taking that action is going to take me from state A to state B, right? And if I know that that action takes me from state A to state B, that might be helpful in general. Like that, I don't know if that's a good state to be in, but I know that that's the state that it's going to take me to, right? And that information is important, and that comes with unlabeled data. And unlabeled data, like you can probably imagine, is much easier and much cheaper to collect. So we can have a lot more unlabeled data that gives us a lot of information about how these transitions between states actually works, right? Like what states are we actually, if we take a given action in a given state, where are we going to go to? And then that information can be helpful for learning better models.
Yeah, in this particular case, one thing that I understand is there's a lot of inference about the environment and about the impact of the action, right?
Yeah.
Not all of those are clearly identifiable. One of the things that we've seen in other areas of ML is that wherever there are proxy or inferences, there is always an issue of validating against the ground truth, and there's also challenges with reference to bias or even the governance issues that crop up in those environments. Do you see that this open problem of unlabeled data or leveraging unlabeled data will also create or has the other side of the problem in this context?
So, sorry, just to make sure I understood your question, you're trying to see if leveraging unlabeled data might have issues in the context of governance and security, that kind of thing,
Governance,
right?
ethics, in that sense. So more today,
Yeah,
because there is a lot of inference involved in it, right? Because these are
of course.
unlabeled, right? Because there is inference involved in it, inference has a judgment involved in it, and those judgment, in whatever way it is formulated, again, that will have ethical issues associated with. That's what I'm just trying to understand.
Yeah, I perfectly agree with the fact that there are ethical issues with, there's a lot of bias involved. But on the other hand, one thing that I actually think is an advantage of using unlabeled data is that sometimes your labels have bias in them, right? So mainly when you're working with RL, let's say that you're trying to see how good a drug was for a given patient. Maybe that evaluation of how good that drug was has some bias in it, right? Maybe it's you were biased because, I don't know, you evaluated something, you thought that the patient looked well when he didn't, just because, I don't know. There has labeling stuff has a lot, is much more subject to bias than unlabeled data, right? Unlabeled data is basically raw data that you have, right? It gives you information about actions that you took and the states, the starting state and the end state, right? I feel like that's much more much less prone to bias than trying to label these. Let's say that you want to use labeled data and then you try to label that data and you label it incorrectly. That's much more
A
harmful for
complex
your
problem,
algorithm.
yeah. Yeah,
Exactly.
I
So I
understand.
feel like there are issues, like if you use that unlabeled data incorrectly, or if you only have unlabeled data for a specific set of people, then you're not going to be able to generalize to another set of people. But I feel like it's overall it's a better direction if you're trying to remove things like the bias that might come from labeling that data incorrectly, right?
Super. I think this has been a very interesting conversation that we discussed about the concept of offline reinforcement learning, the open problems associated with it in two parts. And I'm happy about we having covered some of these areas. I'm sure the audience will have greater insights from this podcast. And I hope some of you may reach out to you to seek more information on some of the things that you've spoken about. I'm glad to have you here and look forward to talking to you again. Thanks a lot for agreeing to participate and sharing your insights on this.
Yeah, thank you so much for having me. It was a pleasure also to have this conversation with you.
Thank you.